All right, get ready because today we're going deep, really deep into some brand new AI research.
Yeah, some really interesting stuff.
We're going to be talking about a whole new way that AI might be able to reason.
Yeah, and this isn't just about processing language.
It's about like tapping into something much deeper.
Right. Like, what's really fascinating about this is that it kind of challenges the whole assumption that we've had.
Yeah.
That language is like the end-all be-all of intelligence.
Interesting.
So this paper, training large language models to reason in a continuous latent space.
Okay.
They actually propose this, well, they call it coconut, this new method.
Coconut. That's kind of a catchy name. So what, are they saying that our current LLMs, our large language models, are limited because they rely so much on words?
Yeah, exactly. Like, think about it this way.
Okay.
Imagine trying to solve a complex math problem.
Oh, okay.
But you can only use English words.
Oh, wow.
No numbers, no symbols.
That sounds really hard.
It's doable, but it would be so inefficient, right?
Yeah, definitely inefficient.
And it's funny because when you actually think about it, like when we're solving logic puzzles, our brains, they don't necessarily light up in those language centers.
That's true. I never thought about that.
There's something else that's happening there.
It's like, yeah, you're not consciously like forming sentences in your head.
Right.
When you're trying to solve a riddle or something.
Exactly. So how does this coconut method actually work?
I'm curious.
Well, it doesn't ditch language entirely.
Okay.
It starts with language data, but it goes beyond the constraints of words.
Okay.
So instead of generating like a chain of word tokens, like the traditional chain of thought methods, Coconut uses the last hidden state of the LLM.
Okay.
And this hidden state, you can think of it as like a compressed, continuous representation of everything the model understands.
Oh, so it's like the model is building up this complex understanding.
Yes.
In its mind, but it's not just a string of words.
Right.
It's something way more, I don't know, richer.
Yeah, nuanced, exactly. And this is where it gets really interesting.
Okay.
This hidden state, this continuous thought, becomes the input for the next step in the reasoning.
So it's not limited to just like one word at a time.
Exactly. So instead of just a single word, it considers multiple potential next steps.
Oh, wow.
At the same time.
So it's almost like it's doing like a breadth-first search.
That's a great analogy.
Exploring all these avenues at once.
Exactly. And that ability, that's what makes it so powerful. Especially for these problems that really need planning and strategizing.
I can see that, yeah.
Like it's thinking ahead.
Yeah, okay, I'm starting to see how powerful this could be.
Yeah.
But how do you train an AI to reason this way?
Right.
It seems so complex, this abstract, non-linguistic way.
It is, and the training is a big part of what's new here.
Okay.
They have this multi-stage curriculum. It starts with standard chain of thought data, where the reasoning is expressed in language.
Okay.
But then they gradually, over several stages, replace the language steps with these continuous thoughts.
So it's kind of like, you know, starting with training wheels.
Yeah, like slowly taking the training wheels off.
And then getting to this whole new realm of reasoning.
Exactly. It's giving it that bridge.
Yeah.
From language to this latent space.
But why is that gradual approach so important?
Well, it seems like the model really needs that initial grounding in language.
Okay.
To really learn how to work in this latent space.
Interesting. Like imagine trying to learn a new language, but you have no reference point, no Rosetta Stone. Yeah, that would be really tough.
It would be super difficult.
Yeah. This is fascinating. I have to know, like, does it actually live up to the hype?
Right.
Does it actually work better?
Well, that's the big question, and the results are pretty impressive.
Okay, tell me more.
So they tested Coconut on 3 different data sets.
Okay.
1 for math reasoning and then 2 for logical reasoning.
All right.
And it outperformed standard chain of thought across the board.
Really?
Yeah, and it was especially good on the tasks that required complex planning.
That's so cool. So it's like, it's really good at the stuff that other models struggle with.
Exactly, like where they get bogged down in the detail.
Yeah, yeah.
Coconut can kind of see the bigger picture.
Wow, okay, this is blowing my mind.
It's pretty wild.
We've talked about the how, but now I'm even more curious about the why.
Yeah, the why is a big one.
Why is it that operating beyond language seems to be so much better for this kind of reasoning?
That is the question.
Is there something inherently, like, inefficient about using words to think?
I think that gets to the heart of why this research is so groundbreaking.
Okay.
So language, it's a powerful tool for communication.
For sure.
But it might actually be a bottleneck for thought.
Oh, interesting.
Words, they're just these discrete symbolic representations, and they don't capture the full richness and complexity of our thoughts.
It's like trying to fit a square peg in a round hole.
Exactly. You're forced to simplify. Yeah, break things down into these like manageable chunks.
But you lose some of the nuance, right?
Exactly. You lose that connection, that nuance.
Yeah.
And that's where continuous thought with Coconut comes in.
Okay.
It can represent these concepts and relationships
Yeah.
in a more fluid and holistic way
Oh, wow.
without those limitations of individual words.
It's like it's thinking in pictures or feelings rather than words.
It's more intuitive, less structure.
Yeah, less rigid.
Exactly.
This is incredible. So is that why it's so good at those complex tasks?
It might be, yeah.
Because it can plan and strategize without getting lost in the words.
Right. It's not getting bogged down.
Now, this is really making me think differently about how AI works.
That's what we're here for, to expand your thinking.
Well, mission accomplished. I feel like I need some time to process all of this.
It's a lot to take in.
It really is. But this is just the beginning of our deep dive into coconut, so stay tuned because there's so much more to explore.
We're just getting started.
We'll be back after the break to delve into the potential impact of this technology on the world.
The good, the bad, and everything in between.
Exactly. Don't go anywhere. We'll be right back.
No.
Okay, so we're back and I'm ready to keep digging into this coconut thing.
Yeah, let's dive back in.
We left off talking about understanding coconut's reasoning, if it's happening in this latent space beyond language.
Right.
It's like, how do we understand what's going on in there?
It's a tough one, but the researchers have some pretty clever ways to try and decode those continuous thoughts.
Okay, I'm listening.
So remember how we were talking about the hidden state?
Like that compressed understanding?
Exactly. Well, they can actually analyze how that hidden state changes over time.
So they're like watching it as it thinks.
Yeah, kind of. They're tracking those changes, seeing how it evolves.
Oh, that's cool. So they can like see the breadcrumbs of the thought process.
Exactly. Oh, hey, welcome. What's up?
Hey there, why don't we compress the hidden state to the token level?
That's a really interesting question. It's kind of like you're asking how much the model is thinking versus how much it's talking.
Yeah, like, is all of this latent reasoning just some fancy way of saying it's using more compressed tokens?
Well, the researchers actually looked at that. They found that this latent approach, Coconut, actually uses fewer tokens overall.
Oh, interesting. So it's not just compressing things, it's fundamentally more efficient in its process.
Exactly. It's not just about making the words shorter. It's about finding a different way to represent the thought process entirely and in fewer steps.
Okay, that makes a lot more sense. It's thinking more and talking less, in a way.
Yes, and that is a big deal when you're solving complex problems.
So they aren't just using shorter words, they're using less words overall.
Right, and we'll get more into that when we talk about the value functions.
Value functions, what are those?
So basically, it's an estimate of how promising a path looks to the model.
Oh, so it's like the model is saying, this path seems good, this one not so much.
Exactly. It's like it's ranking the different options based on, its understanding of the problem.
But how can they measure that?
Oh, yeah,
Thank you for your explanation. Can we just go through the key points of this study?
Oh, absolutely. I'm glad that explanation helped. Let's recap the key points for you.
Yeah, that's a great idea. It might help to solidify some of these more complicated ideas.
Okay, so the big problem that this study is tackling is that current large language models, or LLMs, they rely so much on language for reasoning.
Right. They use things like chain of thought, where they generate these long strings of text to explain their reasoning.
But the thing is, our brains don't really work like that. When we think, we don't necessarily form sentences in our head.
Exactly. Brain scans show that the language parts of the brain aren't very active during reasoning tasks.
So this new approach, Coconut, it's trying something totally different. It reasons in what they call a latent space, not in language space.
Yeah, they use the model's hidden state, which is like this compressed representation of all the model's knowledge, as the basis for its reasoning.
And it's like, instead of thinking in words, it's thinking in this more abstract and continuous way.
And this continuous thought can represent multiple options, allowing it to perform like a breadth-first search of potential solutions.
That's different than traditional methods, which can only explore one path at a time. This helps it solve complex planning problems.
Right. And to train the model, they use this multi-stage process. They start with language-based reasoning data and then slowly transition to this latent space reasoning.
And the results are that Coconut can actually outperform chain of thought on some really complex problems, especially ones that require planning.
Plus, it uses fewer tokens overall, making it more efficient, and the model develops these value functions, which allows it to evaluate how good each potential path is.
So it's not just blindly searching, it's making judgments about what's likely to work. It learns its own kind of intuition.
Yeah, so it's a totally new way to approach reasoning in AI. It's more efficient.
Oh, yeah. Uh-huh.
Thanks for the overview of the incubation.
Okay, that's an interesting point you bring up. It seems like you're referencing something outside of the immediate context of the paper, but I think I can see where you're going with this. It sounds like